Welcome to Hartman Math. This is lesson 2.6. We're going to be graphing quadratic functions from Vertex Form. We saved the best for last. This is the easiest one. So here's our generic Vertex Form for a quadratic function f of x. A, we've already seen what A does. It's the same in all of our quadratic functions. It tells us if it opens up or down. It tells us if it's a wide parabola or a narrow parabola. We have this where some quantity is being squared, x minus h squared plus k. The vertex is the point h comma k. So number, common number right there leads us to the vertex. It's the most important point on the parabola. So if we just look at it, it's telling us the vertex. Let's take a look at our function here. Example number 1, k of x equals. We're kind of looking for our form here, a times x minus h squared plus k. So a, pretty easy. We see it right there. That's the 2. So right away, is it going to open up or is it going to open down? It's going to open up. In comparison to our x squared parabola, is it narrower or wider? It's going to be narrower a little bit. All right, the tricky part, x minus. What number makes x plus 1? It's the same thing we've been looking at before. The easiest way is inside the parentheses in this form of x minus. Just think opposite. It's negative 1. Minus negative 1 becomes plus 1. And then at the end, after the squaring, what you see is what you get. It says minus 5. That's a negative 5. So our vertex is h comma k. H comma k. Negative 1 comma negative 5. So we should be able to go right from here to that vertex. Think opposite. Negative 1. What you see is what you get. Negative 5. Negative 1 comma negative 5. All right, let's write the axis. And what we really mean is the equation of the axis of symmetry that would go vertically and pass right through that point. It's always a vertical line. It's always x equals, and there's our x. So it's x equals negative 1. We can draw that. For the rest, if we wanted to create a table, we'd make negative 1 the middle x, negative 5 the middle f of x, and we could do values like 0 and 1, negative 2, negative 3. We could also do our pattern of the odds. So right 1, up. I think it's up. We already said it was up because A is positive. Up the first odd number, but always multiply by A. So we're going to multiply by 2. So 1 times 2 is 2. We're going to go right 1 up 2. So right there, if we were asking for the y-intercept, you kind of see it. We're on the y-axis. 0 comma negative 3. If your graph doesn't show it, plug in or substitute a 0 for the x value. That's always how to find a y-intercept. All right, and then we need a couple more points. So right 1 up. The second odd number is 3. Always multiply by A. 3 times 2 is 6. We're going to go right 1 up 6. Same on the left. Got our parabola. And we're going to draw it out. Nice curve with arrows. See if we can analyze some of the things that we've been looking at about our function. So domain, range, all of that stuff. It's quadratic. We already know the domain. The range, how low, comma, how high. Where is it going? Up, starting here at an x-coordinate of negative 1. Going to the right forever. Where is it going? Down. Remember, as we trace from left to right, we're going down in this section. starting at, going left forever there, negative infinity, all the way till negative 1. Now, positive and negative is a little tricky. I'm not sure we can be exact on these ones for this particular parabola, quadratic function. Later, in future lessons, we're going to see how to get exact values for where we're hitting the x-axis. Right now, we're just kind of eyeballing it and guessing. So positive would be, hey, we're above right here. So from negative infinity, and it looks somewhere between negative 3 and negative 2, just slightly closer to negative 3. Maybe it's negative 2.6, approximately. And then over here, above, so 0.6 to infinity as an approximation. And then the negative clearly would just be the other part between those. So between negative 2.6 and about 0.6. All right, as x approaches infinity, going right on the graph, we are going up forever. As x approaches negative infinity, going left on the graph, we are going up forever. This one has a minimum lowest value. The value is the y-coordinate, negative 5. It happens when x is negative 1. Example number 2. P of x is equal to negative quantity, say that for parentheses, x minus 2 squared. Looks like there's maybe some stuff missing. That's okay. ID the vertex. The x-coordinate comes from what's being squared. Look inside the parentheses. Think opposite. 2, comma. Now what about the k value, the y-coordinate for a vertex? That's typically after the squaring. Anything that's being added, maybe subtracted. But there's nothing out here. So what is it that we're adding? What number? Plus 0 to make it invisible. So our vertex is the point 2, 0. Axis would be the line that passes right through there. X equals 2. We could do our pattern of the odds to get the other required points. Right 1. First odd number is 1. Multiply by a. Ooh, there's a. It's actually a number, negative 1. Think of that as a 1. So negative 1 times the first odd number of 1 makes negative 1. So that would say go down 1. Right 1, down 1. Right 1, down. Well, the second odd number is 3. Times negative 1, negative 3. We already knew we were going down. So let's go right 1, down 3. And again, if we were asking for the y-intercept, we would see it on the graph right there. 0, negative 4. If they were asking for x-intercept, sometimes we may not know how to find them, like in the last one, we would be guessing. But this one, we know that's on the x-axis, 2, 0, and it's the only one. But there's our graph. All right, go ahead and pause the video here as you try to identify the vertex and the axis of symmetry. Get your 5 points based on the function a of x. It looks like it might be standard form. Yeah, maybe it is. But this is actually also vertex form. So see if you can look at it and go right to the vertex. Pause here. Hit play when you're ready. All right, so we don't have any parentheses this time, but it still is in vertex form because we've got the a times x minus h squared. What would be the h? X minus what is the same thing as x? And that would have to be 0. X minus 0, if we subtract 0, we haven't changed anything. That's the same thing as x. So the h is 0. X-coordinate is 0. 0, what's after the squaring? What you see is what you get, a positive 1. 0, 1. That means the axis of symmetry, x equals 0. draw that. We can do pattern of the odds to get the other points. Write 1 up. First odd number is 1 times A being a half. We're going to go up a half. Write 1 up a half. From there, write 1 up 3 is the next odd number. Multiplied by a half, you get 3 halves, or 1 1/2, or 1.5. Write 1 up 1 and a half, puts us right there. So if they asked for the y-intercept, it would be 0, 1. If they asked for the x-intercept, it doesn't have any. It's completely above the x-axis. If it asked for where is the function positive, the whole thing is positive. The whole thing is above, from negative infinity to positive infinity. Where is it negative? Nowhere. There's nowhere down here. So that would be a none. Okay. So there's our another one looking at kind of a special case there on vertex form. We're going to wrap up with a little bit of factoring practice. Go ahead and pause here. Go ahead and work these out. Solve by factoring. It does say solve, so we're going to get x equals kinds of answers. Pause until you're ready. All right, first one is ready to go. It says equal to 0. We're ready to factor. There's no GCF. 2 sets of parentheses. We call that double bubble. How are we making 2x squared? That would be a 2x and an x. Let's look at the constant. Our choices are factors of pairs 1 and 9 or 3 and 3. I think the one that works is 3 and 3. Let's do a quick check on that. Outside, 6x positive plus 3x makes 9x. We've got our winner. Split them apart. Set them equal to 0. Solve for x. X equals negative 3 over 2. Over here, x equals negative 3. Let's look at part B. It's not ready to factor. Got to make it equal to 0. Like the positive x squareds here, let's subtract a 48 on both sides. Our first factoring method is always GCF. Hey, there's a 3 in common. Let's factor out the 3. Then we have 2 terms here. The way that we've looked at those is maybe it's a difference of squares. Difference, yes. Is that a square? Yeah, it says it right there in the name. Is 16 a square? Yes. So we'll split that up. Kind of looks like 2 sets of open parentheses like before, just special. The fronts have to be the same. We're looking at x and x to make x squared. Backs have to be the same. What times what makes 16? Got to be the same. It's 4 and 4. One's a plus, one's a minus. Doesn't matter which one's which. Split them up. Can't really set 3 equal to 0. That doesn't make any sense. So we're really only going to focus on the factors that have x in them and solve from there. We've got our 2 solutions there. That's it for today. See you next time.